Staring down a completely blank periodic table feels exactly like being dropped into a shifting labyrinth of letters. To anyone trying to learn the S, P, B, and F blocks for the first time, the grid looks like a chaotic jumble of symbols with no clear path forward. We are changing that right now. In exactly 6 minutes, you'll be able to fill this entire grid from memory using a few specific, easy-to-recall stories. Before we start the clock, grab a blank periodic table worksheet and a pen. You are building this out with me in real time. Learning the exact address of every element ensures that when you need to calculate reactivity or determine group trends, you aren't wasting time fighting the chart itself. Our starting point is the far left, the S block. The direction is the key here. We are memorizing these elements straight down the columns, from top to bottom. For Group 1, we follow the story of a student named Helena who is praying for her medical exams.
Write Helena ki roop se faryad. This maps out hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Now Group 2. This time, a kid gets greedy with his demands. Write Beta mange car scooter baap roye. That gives you beryllium, magnesium, calcium, strontium, barium, and radium. Dropping down these two columns secures the left side of your table, creating a structural anchor for the transitions we'll handle later. Skip across the middle to the far right, the P block. Maintain the vertical direction. We are still reading straight down. Group 13 is a market trip. Bangan, Aloo, Gajar in Thela. For Group 14, think of pilgrims. Kashi gaye Sant Prabhu. Group 15 is about a cricket match where the rival teams are struggling. Using the phrase newspaper aaj sab bike, you lock in nitrogen, phosphorus, arsenic, antimony, and bismuth. For Group 16, imagine someone cheating on a test. Old style se TPO. That gives you oxygen, sulfur, selenium, tellurium, and polonium. Let's finish the vertical drops. Group 17 is the neighbor. Pair, gal, bahar, ai, auntie. And for Group 18, think of a medical scan. Hina, Nina, or Karina ka X-ray rangin. Check your progress. The outer boundaries of your table are now fully built, leaving only the empty space in the middle to be filled. Warning: the direction is now changing. To fill the center D block, we abandon columns and read horizontally across the periods. For 3D, scooter, T, vaha, criminal, mun, fair, kyon, nahi, kyon, sanab. Next, 4D, Yama, Zara, Moab, most, Tara, Rute, Rata, Pudhoge, Age, Kenya. Each starting letter maps to its symbol, like scooter to SC, moving horizontally. Learning these horizontal sequences bridges the gap between your S and P blocks, structurally locking the entire center of the table together.
If you've taken a chemistry class, you know the exact moment the periodic table stops making sense. It's right here, in the D block. You're suddenly asked to manage 30 transition metals and their electron configurations, only to find the standard rules for orbitals spinning completely out of control. Rote memorization often falls apart under the pressure of a timed exam. The sheer volume of exceptions makes it difficult to rely on willpower alone to keep every configuration straight. We can solve this with a simple 3x10 grid. When combined with 3 specific mathematical patterns, this grid predicts every single electron configuration in the D block with total accuracy. Relying on these patterns removes the guesswork. Once the structure is set, the correct answers calculate themselves. The 3D foundation begins with a mnemonic. Science teachers very cruel, may not feel cold nights, cute zebras. This places scandium through zinc. The configuration follows a standard count, maintaining a 4s2 shell while the 3d count increases by 1. Scandium is 3d1, titanium is 3d2. However, nature favors symmetry. Atomic orbitals are most stable when exactly half full, with 5 electrons, or completely full with 10. When an atom is 1 electron away from these milestones, it will adjust its structure to reach that stability. We see this with chromium. A standard count puts it at 3d4, but it borrows an electron from 4s to reach 3d5, 4s1. Copper follows the same logic. To reach a perfectly full 3d10 shell, it pulls an s electron, resulting in 3d10, 4s1. These atomic structures give the 3D series immense physical strength. Elements like iron and chromium provide the structural foundation for industrial infrastructure and steel production. Conquering the 3D row is a matter of counting and shifting a single electron to achieve perfect symmetry. The 4D series uses a different phrase, yes, zur Knob. Most technicians rub Rod's pale silver Cadillac. To predict these configurations, the d orbital count completely rejects three numbers, 3, 6, and 9. We start counting normally, D1, then D2. But when we reach niobium, where D3 should be, we skip the band number. Niobium jumps ahead, absorbing an s electron to become 4d4 5s1. Continuing the count while skipping 6 and 9 creates a cumulative displacement. By the time we reach palladium, it absorbs both outer s electrons to reach a unique 4d10 5s0 state. These orbital shifts result in the highly stable electron structures found in silver and palladium, giving these metals their valued non-reactive and corrosion-resistant properties. Omitting 3, 6, and 9 from the count perfectly predicts 6 separate orbital exceptions that would otherwise require individual memorization. The 5D series uses the phrase, Larry's half taken, Wendy reached ostrich irritating pets, gold, mercury. But notice the massive atomic jump between lanthanum and hafnium. This lanthanide gap means configurations from hafnium onward must include a full 4F14 shell. The counting rule for this row is even more focused, rejecting only the number 8. Counting across while skipping 8 causes platinum to jump to 5d9 6s1. This displacement then pushes gold into its stable 5d10 6s1 configuration. The orbital density here creates unique physical states. Mercury's electrons are held so tightly by its full d10 orbital that the metal cannot form solid bonds at room temperature, remaining a dense liquid. Navigating these heavy transition metals is a matter of accounting for the atomic gap and skipping a single digit. This master grid organizes 30 distinct metals and their precise electron formats into a single visual tool. Drawing this box and skipping those 4 specific numbers automatically resolves every difficult exception in the block. At the start of a chemistry exam, sketching this structure on scratch paper provides a reliable reference for dozens of configuration questions. Mastering chemistry involves recognizing the hidden mathematical rules that govern the chaos. Once you see the pattern, the work is already done. Finally, look at the 2 detached rows at the very bottom. We are staying horizontal for these as well. For lanthanoids, use this story. सीने पर नदिया प्रेम की समाई, यूं ही गदगद तब दिल हुआ, और तुम लाजवाब लगती हो. For actinoids, a cafe order. थोड़ा पापड़ यूं ही नापो, पुराने आम कम बिकेंगे, cafe में ऐसे फरमाओ, Madam Noodles lao. These rows often cause the most anxiety during chemistry exams, but linking them to these 2 sentences ensures that every blank space on your sheet is now accounted for. Look at your page. You now have a fully populated 118-element table. You've moved from staring at an empty grid to possessing a complete atomic map, eliminating the risk of blanking out during a test. I want to know which specific story was the easiest for you to remember, the market trip, the scooter story, or the cafe order. Tell me in the comments. To make this permanent, print 3 more blank tables right now and test your recall while these stories are still fresh. Go build your map.